Hello students, this is the part 2 video for the physics examination revision for grade 9 advanced, and in the first video, that is the part 1 video, we have discussed from question number 1 to question number 8, and today we will discuss from question number 9. Question number 9 is about free fall, and in the revision material, that is in the EOT, two examples given, that is question number 43 and 44 from page number 77 of your textbook. So before we go to the questions, first we will discuss what is free fall. If an object is falling freely, for example, if I drop this marker, it is falling. That is called free fall. If an object is in free fall, the only force acting on the object is force of gravity. Here the only force acting on this marker after I drop this is the gravitational force exerted by Earth on this object. So first point about the free fall, the only force acting on an object in free fall, that is the gravitational force. So in this case, this gravitational force is applied by Earth. Earth is applying this gravitational force. So gravitational force by Earth. Number 2, if an object is in free fall, for example, if I drop this object, its velocity is increasing, right? Its velocity is increasing. Or we can say, if you are throwing an object upward, for example, I am throwing this marker upward like this. So what is happening here? When the marker is going up, it will reach the maximum height, then after that it will fall down, right? Yeah. So when it is going up, when the marker is going up, its velocity is decreasing, okay, during upward motion. So here this represents the upward motion, okay, so this represent upward motion, this is representing downward motion. So when I throw this marker, what's happening? The marker is going up, then it is reaching the maximum height, after that it is falling down. So when it is going up, when it is moving upward, the velocity is decreasing. Velocity is decreasing. That is one thing, velocity is decreasing. Another thing, what is the direction of the velocity? Upward, right? Velocity is upward. Velocity is upward and decreasing. As velocity is upward, here we will take the upward direction positive. So we can say, as velocity is directed upward, velocity is positive and decreasing. If the velocity is decreasing, we have discussed in the part 1, if the velocity is decreasing, what is the acceleration? Positive or negative? If velocity is decreasing, then acceleration is negative. So during upward motion, acceleration will be equal to negative 9.81 meter per second squared is the unit. So during upward motion in a free fall, the value of acceleration is negative 9.81. Why negative? Because its velocity is decreasing. And what about the velocity? Velocity will be positive. Why the velocity is positive? Because the direction of velocity is upward during the upward motion. Here we will consider upward direction positive, and so it's going up, okay, the marker is going up and it will reach the maximum height. So when it reach this maximum height, its velocity become 0. So at a maximum height, its velocity is 0 and acceleration will be negative 9.8, okay, negative during the upward motion. Acceleration will be negative 9.8 1 meter per second squared, that is the value of the acceleration. After it reach maximum height, will the marker stay at maximum height? No, it will fall down, right? While falling down, what is the direction of the velocity? When it is falling down, the velocity is directed downwards. As velocity is directed downward, we will write velocity is negative. Why negative? Because its direction is downward. We will consider the downward direction negative. Then what happens to the velocity? Will it increase, constant, or decrease? When an object is falling down, its velocity will be increasing. Velocity is negative and increasing. As velocity is increasing, acceleration will be positive. So acceleration, that is equal to, I am not writing completely, acceleration is equal to positive 9.81 meter per second squared. So these are the basic things about the free fall. Now we will go to the questions that is given in the textbook. Question number 43 here. A tennis ball is thrown straight up with an initial speed of 22.5 meter per second. So it's like a free fall also. It's a part of equations of motion. Whatever the problem that we are solving in free fall, it is same as how you are solving the equations of motion. So yesterday we have in the last video we have discussed whenever you are solving the numerical problems by using the equations of motion, first you need to write the 5 ingredients, that is the initial velocity, final velocity, displacement, acceleration and time. 1, 2, 3, 4, 5. A tennis ball is thrown straight up with an initial speed of 22.5 meter per second. So when you read the question, you write what is given in the question, 22.5 meter per second, that is the initial velocity. It is caught at the same distance above the ground. How high does the ball rise? So you need to calculate the displacement. You need to calculate the max, how high it will reach. So you need to calculate the maximum height reached. What else given? So this is a question A. Okay, in question in the section A of this question, you need to calculate the displacement. Nothing else is actually given in the question, but we know something. What we know? We know that if the object is moving up, the acceleration will be negative 9.81 meter per second squared. We have just now discussed that. Then what else is given? One more thing given. Not given in the question, but you can understand that because it's a free fall motion, right? When it reach maximum height, what is the velocity? 0. So final velocity is 0. Time not given. Why are we writing not given? So that we will know which equation we need to use. So what are the equations here? What are the equations of motion that you have? We have 3 equations, right? Number 1, final velocity Vf, that is equal to velocity initial plus acceleration into time. Equation number 1. Equation number 2, displacement, that is equal to velocity initial into time plus half multiplied acceleration multiplied time squared. Equation number 3, final velocity square, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x. When will you use the equation number 1? So you can see out of these 5 ingredients, initial velocity, final velocity, displacement, acceleration, time, only 4 will be there in one equation. One of these 5 will be missing in the equation. So just identify which one is not here. Here you can see in this equation delta x, displacement, is not there. So if our displacement is not in the question, you can use equation number 1. So in the second equation, when will you use that? In second equation, you can see final velocity is missing. So if Vf is missing in the question, you will use equation number 2. In the third equation, you will see time is missing. Time is not there in equation number 3. So if there is no time, if time is not given in the question, you will use equation number 3. So here in this question, time is not given, so we will use the equation number 3 to solve this question. Okay, equation number 3, final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x, and we want to find delta x, that is the displacement. Final velocity is 0, initial velocity is 22.5 squared plus 2 multiplied negative 9.81 multiplied delta x. So our equation will be like this. When I solve this, delta x, just rewriting the equation, 22.5 squared divided by 2 multiplied 9.81. .5 squared divided by 2 multiplied 9.81 that is equal to 25.8. 25.8, and the SI unit of displacement is meter. Now we will go to the next question. So like here we have another section, okay, section B of the question. How long does the ball remain in the air? Tennis ball, yes, it is caught at the same distance above the ground. So first question part, how high does the ball rise, that we have done, we have calculated. And second, how long does the ball remain in the air? For example, this is the ball. So I am throwing this ball up and catching the ball at the same height. So what is the total time taken for the ball, that ball spent in the air? Here we need to calculate the time. We need to calculate. We need to calculate the time, and the maximum height we already calculated, and it was how much? .5 squared divided by 2 multiplied 9.81, 25.8, right? So this one we have calculated, and we got this value 25.8 meter. Okay. Now we want to calculate the time. Okay, in question B you need to calculate the time. So here you are throwing the ball. So the ball is moving like this, then it is reaching the maximum height, and it is you are catching the ball at same height. So this side represents the upward motion, and this side is representing the downward motion of the ball. So here to calculate the time, first what we will do is, we know the velocity here, it is maximum velocity is 0, and initial velocity, that is 22.5 meter per second squared, meter per second, that is the value of the initial velocity. So what we will do is, we will calculate the time taken to reach maximum height. What? We will calculate time taken by the ball to reach maximum height. Means we will calculate the time for the upward motion. Then how will we get the total time? Multiply your answer by 2, because time taken to travel from here to here, and the other half of the motion, like from here to here, is same. So first what we are calculating, we will calculate the time taken from the ground to reach the maximum height, and we will multiply that time by 2, so we will get the total time. So I will use this equation, final velocity, that is equal to velocity initial plus acceleration into time. the value of final velocity when it reach maximum height velocity is 0, and initial velocity when we are throwing it, we are giving an initial velocity of 22.5 plus acceleration when it is moving up, acceleration is negative 9.81 into t. When you rewrite this equation, t is equal to 22.5 divided by 9.81, that is equal to 22.5 divided by 9.81, that is equal to 2.29. So I will just write 2.3 second is the time taken to travel from here to here. How much? 2.3 second. So what is the total time? This half will be 2.3 second. So the total time that will be equal to 2 multiplied 2.3, right? Which means 2.3 plus 2.3, okay? That is same as 2 multiplied 2.3, so 4.6 second. 4.6 second is the total time taken, or the total time the ball spent in the air. Then next we will go to the next question, question number 44. Question number 44, you decide to flip a coin. The coin is flipped straight up. What are the velocity and acceleration of the coin at the top of its trajectory? For example, like this, you are flipping a coin. So what is its velocity and acceleration when it reaches the maximum height? That is the section A of that question, section A of that question. Okay, section A of that question. What is the velocity, right? At a maximum height, velocity will be 0 and acceleration is equal to negative 9.81 meter per second squared. That is the value of the acceleration. Now we will discuss the question B. If the coin reaches a height of 0.25 meter, so the coin is reaching a height of 0.25 meter. Height means displacement, right? 0.25 meter, it is reaching that height. Above where you release it, what was its initial speed? So you need to calculate the initial speed. What else is given? You know anything given? Nothing else is given in the question, but you know that in free fall and when it is moving up, acceleration will be negative 9.81 meter per second squared, and you know that when it reach maximum height, its final velocity will be 0. Time not given. What do you want to calculate? You want to calculate its initial speed, right? Initial speed you want to calculate. If the time is not given, which equation will you use? If time is not given, t not given, so you will use the third equation, okay? Equation number 3. That you will use. So final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x. Final velocity 0, 0 squared is 0. Initial velocity squared, that we need to calculate, right? So initial velocity squared plus 2 multiplied negative 9.81 multiplied delta x. Delta x, that is displacement 0.25. So what we will get, I'm rewriting the equation. Initial velocity squared, that is equal to 2 multiplied 9.81 multiplied 0.25, that is equal to where is calculator? 2 multiplied 9.81 multiplied 0.25, that is equal to 4.905. 4.905. Alright, so what you need to calculate? You need to calculate the initial velocity. So initial velocity is square root of 4.905 905, that is equal to square root answer, that is equal to 2.2 meter per second. That is the unit for the velocity. Meter per second is the unit of velocity. Question C, okay, section C of this question. If you catch at the same height as you release it, how much time was it in the air? We have discussed the same type of question in 43 also. In section here we calculated the initial velocity, right? Yeah. Then in section C of the question, you need to calculate the time. You need to calculate what? You need to calculate time. So how will you calculate time? Here also, like a time for which the coin is in the air, time for going up plus time for falling down. So first we will use this equation, final velocity, that is equal to initial velocity plus acceleration into time. Final velocity is 0, initial velocity we calculated how much? 2.2, right? 2.2, acceleration negative 9.81, negative 9.81 into time. Time I will write t. T we need to calculate, right? So t, that is equal to, if I rewrite this equation, 2.2 divided by 9.81, that is equal to 2.2 divided by 9.81, that is equal to 0.22 second. 0.22 second. Is this the final answer? Is it the total time for which the coin in the air? No, right? Then how to find the total time? Multiply this answer by 2, because this is only for the half of the motion to reach the maximum height. Coin will not stay at maximum height, it will fall down. So to get the total time, to find the total time, you need to total time that is equal to 2 multiplied 0.22, right? 0.22. So your answer will be 0.44 second. 0.44 second. You may feel difficult because I have written at the bottom of the board and I am not sure whether it is if you are able to see in the video. So the answer is 0.44 second. I hope you understand this. If you have doubt, you can ask in the comment or you can ask in the WhatsApp. Students, when we go to the next question, that is question number 10. Question number 10. This question is also about the equations of motion. Equations of motion, and we need to discuss questions from page number 72 of your textbook. Page number 72, question number 28, 29 and 30. So these three questions we will discuss. All the questions from equations of motion. So there are many questions, right, from the equations of motion. Okay, so we need to follow the same method. A car with an initial velocity of 24.5 meter per second. So a car is moving east. East means east, we take it as positive, okay, right side, right? So a car with an initial velocity of 24.5 meter per second, its initial velocity 24.5 meter per second, has an acceleration 4.2 meter per second squared, acceleration 4.2 meter per second squared, has an acceleration of 4 meter per second squared west. So this is the origin and this is east and west. The object is moving to this side with a velocity of 24.5 meter per second, but the acceleration is towards west. The direction of acceleration is 4.2, right? 4.2 meter per second squared towards west. West means to the left side. Left side is negative, okay? Left side we will take as Negative. What is its displacement at the moment that its velocity is 18.3 meter per second east? Final velocity 18.3 meter per second. Positive or negative? Positive. Why? Because it is towards east, towards right side, right? East means right. So what do you need to calculate? You need to calculate the what is the displacement. You need to calculate this delta x. Time not given. If time is not given, you will be using equation number 3 as usual. So equation number 3 is final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta x. In free fall, acceleration will be always 9.81. If the object is going up, negative, falling down, positive, but the value will be always 9.81. But here it's not free fall, right? Its object is moving, accelerating. So here the value of acceleration will be different. That will be according to the value given in the question. So final velocity 18.3, right? 18.3 squared, that is equal to initial velocity, that is 24.5 squared plus 2 multiplied acceleration, that is negative 4.2 into displacement. What do you need to calculate? You need to calculate displacement. So rewrite this equation for displacement. So equation becomes like this: delta x, that is displacement, is equal to 24.5 squared minus 18.3 squared divided by 2 multiplied 4.2. So displacement, that is equal to 24.5 squared minus 18.3 squared, that is equal to divided by 2 multiplied 4.2. So I am getting 31.6 meter. 31.6 meter is the displacement traveled. We are getting positive value, which means displacement is directed towards east. Students, now we are discussing question number 29 from page number 72 of the textbook, and this is part of the question number 10 in the your examination revision. In that, a man runs from point A to point B at a speed of 0.5 meter per second for 15 minutes. 15 minutes, when I change into seconds, it will be 900 seconds. 10 minutes 600 seconds, 5 minutes 300, right? So 600 plus 300, so it will be 900 seconds. From B to C, he is moving with an acceleration. So here from A to B, he is moving at a constant speed of 4.5 meter per second. From B to C, he is accelerating, means its velocity is not constant, velocity is increasing, and the value of acceleration is 0.05 meter per second squared for 90 seconds, and the time taken here is 90 seconds. So that is the accelerated motion. So initial velocity there, it will be 4.5 meter per second, right? Because velocity when it reach the point B, the man he reached the point B will be 4.5 meter per second. So from B to C, it's accelerated motion, right? A to B, distance traveled, that we will just calculate like this: 4.5 into 900, because it is a constant, it's a uniform motion, right? The object, the man is moving with a constant velocity. If an object is moving with a constant velocity, then distance traveled or displacement traveled, that is equal to velocity into time. So in that case, 4.5 into 900, that is equal to 4050 meter. That is the distance traveled from A to B. Now we need to calculate what is the distance traveled from B to C. Then we will add with this, so we will get the total distance covered. So here, what is the final velocity? Not given, right? Final velocity not given. Initial displacement we need to calculate. Acceleration, that is 0.05 meter per second squared, and the time is 90 seconds. So if final velocity is not given, then we will use the second equation. So when we use the second equation, delta x, that is equal to initial velocity into time. Initial velocity is 4.5 and time is 90 plus half multiplied acceleration multiplied, that is 0.05 multiplied time squared, that is 90 squared, that is equal to, now we will use the calculator, 4.5 multiplied 90 plus 0.5 multiplied, half is 0.5, right? 0.05 multiplied 90 squared, that is equal to 607.5. 607.5. So what is the total displacement covered? Total displacement, that is equal to displacement traveled from A to B. That is a uniform motion. How did we calculate? Distance traveled is equal to velocity into time. What is the value of the velocity? 4.5. What's the value of the time? 15 minutes. Change 15 minutes into second, 900 second. 4.5 into 900, that is 4050 plus distance traveled from B to C. We are using this equation, right? Distance traveled, to calculate distance traveled from B to C, we are using the equation number 2. Why? Because here velocity is not constant. Here he is accelerating, means he is speeding up. So we need to use the equation with acceleration, and we are getting the value, so 607.5. Now we will add both plus 4050, that is equal to, so I am getting 4657.5, 4658 meter is the total distance traveled by the man. Dear students, next is question number 11. Question number 11 is to explain the meaning of instantaneous position, and we need to explain some questions from page number 40. So first, what's the meaning of instantaneous position? Instantaneous position means position of an object at a particular instant of time. For example, if we mark the position, okay, I am starting from here, from this edge of the board. Then for example, here we have just I will mark 1 meter, 2 meter, 3 meter, 4 meter, or like we will mark up to the other end of the board, like from here 5 meter, 10 meter, 15 meter, 20 meter, like that. And I am taking 4 seconds to reach the other side of the board. For example, if I walk, it won't take even 1 second, but for example, I am taking 4 seconds to reach there. So I am walking like this. 4 seconds I am taking to reach here, and I am moving at a constant speed. So after 1 second, what will be the my position? At 1 second, or after 1 second, that particular instant of time, what is the position? Now it is 5 meter. So that is the instantaneous position. When time is 2 seconds, what is my position? I am at 10 meter away from the origin. So that is the meaning of instantaneous position. Position of an object at a particular instant of time. That is called instantaneous position. And here in this graph, in the example of example problem 1 in page number 40, you can see it's starting from the origin, okay, and position axis, that is the y-axis position. You can see 5, 10, 15, 20, 25 up to 30, like that it is marked, and time axis marked for 1 to 6. So what is the instantaneous position when time is 1 second? Instantaneous position is, just read from the graph like this. Okay, if I show you like this, I think it will be clear in the camera. So instantaneous position at 1 second. So from here you go to the position axis, y axis, 5 meter. What is the instantaneous position when time is 2 seconds? Go here. So instantaneous position is 10 meter. At 3 seconds, 15 meter, like that. Okay, so that is how, that is what about instantaneous position. Then next, question number 12, apply the equations of motion for an object under free fall to calculate the unknown parameters. Same thing, okay, to apply the equations of motion that we have discussed a lot. So I am skipping that question. Okay, if you have difficulty, you can ask for that. So we will discuss in the WhatsApp group, or we will discuss in our revision class on Sunday. And 13, question number 13, again apply the equations of motion under free fall to calculate the unknown parameters. Page number 77, question 40 to 41. Okay, then question number 14, determine displacement using vector addition or subtraction in one dimension. Solve with example. Page number 37. Okay, in page number 37, solve with example. Okay, yeah, this is a very easy question. Okay, very easy. It's like a basic addition and subtraction. So displacement is always what? Displacement. So before that, I will just write the question number 14. Okay, we are discussing question number question number 14, determine displacement using vector addition or subtraction in one dimension. So question number 14, displacement, right? Displacement. How to represent the displacement? We represent displacement by delta x. Displacement is delta x. It's a video one. Okay, displacement is delta x. So displacement that is equal to delta x means change in position, right? Delta represent change, x represent position. So delta x, change in position, change in anything. How to calculate change in position? Final position minus initial position. Okay, if change in position is final position minus initial position. Change in velocity, final velocity minus initial velocity, like that. So here you are traveling. Okay, you are starting from here and you are traveling a 4 kilometer to this side, and you reached here, you reached the point B. From here you again traveled how much? You traveled 2 kilometer and you reached C. What is your total displacement? Your total displacement delta x, that is because you need to add. If you are traveling in the same direction, then add your displacement. Both the vectors, okay, both the vectors are in the same direction, so add 4 plus 2. 4 plus 2 is 6 kilometer. Then next, at one point you are here at position D. You are traveling 6 kilometer. You are traveling 6 kilometer and you are reaching here, position E. You reached here. Then what did you do? You traveled from E 3 kilometers and you reached this position F. What is your total displacement? Your total displacement is delta x, that is equal to 6 kilometer plus what? Plus 3 kilometer. What's the direction of this 3 kilometer? In the opposite direction, right? So negative 3 plus negative 3 kilometer. 6 plus negative 3 kilometer is the displacement. Now we will discuss question number 15. In question number 15, what's the concept? The concept is displacement from velocity time graph. How to calculate displacement if a velocity time graph is given. So I will give you 3 different graph, okay, and we will discuss how to calculate displacement from velocity time graph. So from velocity time graph, displacement is equal to what? Tell, do you know? If a velocity time graph is given, displacement is equal to area under the graph. Area under the graph. So we will discuss about different graph. If it is a velocity time graph, what will be on the y-axis of the graph? The y-axis of the graph will be velocity, right? Velocity on the y-axis of the graph in meter per second, and time on the x-axis. So time, it is like this, for example 1, 2, 3, 4, like that. Then velocity here it is given. I am not writing the values, okay, I am just I will explain how to calculate, okay. I am not doing the calculation here. So for example, our first graph is like this. This is our first graph. This is the graph, right? And the question is, what is the distance traveled or displacement traveled in the first 4 seconds? From 0 to 4 seconds, what is the displacement traveled? You can calculate by calculating the area under the graph. So this is the graph, right? This is the graph. So what is the area under the graph? This much area, right? This much area. I will just shade this like this. So this much area, this is under this graph, right? This much area. So now you can see this area is a rectangular shape, right? Rectangular shape. How to calculate? If it is a rectangle, how to calculate area of a rectangle? If it is a rectangle, area that is equal to length multiplied breadth, right? Length multiplied breadth. So this is the length, right, L, and this value is the breadth. So you can get the value from this side, breadth, from here to here. So you need to calculate area of this rectangle. Displacement is equal to area under what? Area under the velocity time graph, okay? Area under velocity time graph. The next, if the question is what is the distance traveled from 0 to 3 seconds? If the question is from 0 to 3 seconds, then you don't have to calculate the all area, okay? Then you have to calculate area up to this much only, okay, like this section of the graph. Area under the graph up to that time, okay, till the time given. The next, another graph. So here this is time, this is velocity, and if the graph is like this, then what is area under this line? If I mark this area under the line, okay, area below the line, area below the line. So below the line, if you shade the area, you will see the shape of this area is a triangle. How to calculate area of a triangle? If area is a triangle, then you can calculate area that is equal to half multiplied length. So this is the length, right? Half multiplied length of the triangle multiplied, this is the height of the triangle. The value you will get from here, height. The next, another shape, okay, another graph. So this is the velocity time, and for example the graph is like this. This is the graph. Then in this case you will see what is the area. So if I shade this, you will see the shape, it is a trapezoid, right? So you can find area in two different way. One, you can use the equation to calculate area of a trapezoid. For a trapezoid, area is equal to half into a plus b into h, the height. So in this case, a and b are the parallel side of the trapezoid. A and b are the parallel sides of the trapezoid. So this side and this side are parallel. So this we will mark A and we will mark this B. And what is the height of the trapezoid? Height of the trapezoid is this height, this value. So A value you will get from here, or B value, you come to the graph like this. So you will get the value of B, and H you will get the value from here. Okay, then another way is, this is one method. Okay, use the equation of a trapezoid. I told there are two different ways, right? Second way is, you can split this, you can divide this trapezoid into a rectangle and a triangle. Then you calculate area of a rectangle, then you calculate area of a triangle, add both, you will get the area of trapezoid. So this is how you need to solve this type of question. What type? If the question is to calculate displacement traveled from a velocity time graph, you need to calculate area under the graph. Area under velocity time graph, that is equal to displacement. Question number 16. To explain the figure from page number 58, right? Question number 16, and this is from page number 58. So in that a figure is given, and there are four different situations of motion. So first one, you can see the velocity is increasing. I will just draw it. Velocity is increasing. So first we will draw it closer like this, correct? So velocity is increasing here, and the direction of motion also given here. The direction of motion, that is to the right side. Direction of motion is like this. So here is the initial velocity, and this side will be the final velocity because it is moving to the other side. So this I will just mark here initial velocity. Here I will just mark final velocity. Velocity final. So we know that acceleration, that is change in velocity, right? Final velocity minus initial velocity in or divided by time, rate of change of velocity. So here final velocity, that I am drawing like this because final velocity is greater compared to the initial velocity. So this is our final velocity. Direction is to the other side, means to the right side, because it is moving to the right side. So what is change in velocity? Final velocity, see change in velocity delta v, that is final velocity minus initial velocity, right? So minus initial velocity, actually initial velocity vi, that is, this is the initial velocity, right? If I draw here very near to this, this is the initial velocity, smaller, right? Smaller compared to the final velocity, because here velocity is increasing, the object is, the car is speeding up. Then here we need negative of the initial velocity. So this is the initial velocity vi. So what is negative vi? Negative of the initial velocity. Negative means just the sign is opposite. So this is the negative of vi, negative of initial velocity. So negative of initial velocity. Final velocity minus initial velocity. final velocity minus initial velocity, so this much will be cancelled out, right? This part and this one will be cancelled because positive and negative, right side, left side will cancel. So how much is remaining? That is the change in velocity. So this is delta V, change in velocity. So acceleration is actually a function of change in velocity. So acceleration also like this, okay? That is the acceleration. Acceleration is directed to the right side. Then second motion, it is slowing down. In the second one, it is slowing down. So we will draw just to the opposite, like this, and it's moving in the same direction, okay, moving towards the right side, but velocity is decreasing. So this is the initial velocity, that will be greater, means the length will be greater when you draw, and this is the final velocity. Final velocity will be smaller. So here how to write the change in velocity? Here final velocity is smaller, right? So final velocity Vf compared to the initial velocity, the length of the final velocity will be less. Vf minus Vi. So this is Vi, right? So what will be the minus Vi? This is Vi. So minus Vi will be just to change the direction, negative Vi. So Vi, negative Vi. Then when you add this both, final velocity plus negative of the initial velocity, so how much it will be remaining? So this is the positive section and this much will be cancelled out, right? So how much is remaining? This much remaining. So this is the change in velocity, delta V. Acceleration is just a function of change in velocity. So acceleration also we will show in the same way. So this is how you need to do for the other two figure also. Third one I will do, okay, and we will go to the next question after that. So in that case it is speeding up but moving in the opposite direction. So it's like this, it's starting from here but speeding up. Alright, so it's like moving like this. So this is the initial velocity Vi, and because it's starting from the other side, and this is the final velocity, that I will just mark this side, final velocity. Then next when we do it like change in velocity, final velocity minus initial velocity, final velocity I am drawing because it is directed to the left side, Vf. Then initial velocity, it is smaller and directed to the left side, but we need negative of the initial velocity. So what will be the negative of this velocity? Just make the sign opposite. So negative Vi, Vf minus negative Vi, negative of Vi. Then add both, Vf plus negative Vi. So what happens when you add? When you add, this much will be cancelled, right? Positive and negative, when you add, that will be cancelled. So how much remaining? This part, correct? That is your change in velocity, and acceleration is a function of change in velocity. So we will mark acceleration also in that way. Okay, so there is another one more that you can do. You can just go through that. Then next page number 17, describe the motion of an object under free fall during its rising and falling motion, figure 21 and 22, page number 75 and 76. Page number 75 and 76. Okay, so this is about the velocity time graph of an object thrown, okay, of an object in free fall. that we will discuss question number 17. So it's about position time graph and velocity time graph. Question number 17. Free fall. You are throwing this marker, throwing the marker. What's happening? Marker is going up, reaching maximum height, then falling down. The height is increasing, then decreasing. Height is increasing, then decreasing. So when you draw the position time graph, we know that position always on the y-axis, position in meter, time in second. At the first, what's happening? The height is increasing, then height is decreasing. Height is first increasing, then height is decreasing. Height is increasing and height is decreasing. So I'm just dividing this into two sections. So this part represents the marker is moving up and it is reaching the maximum height. Then after that it is falling down. So here you can see this graph is curved, right? It's not a straight line. It's not a straight line. This position time graph is not a straight line. If a position time graph is a straight line, it represents velocity is constant. Why? Because slope of position time graph, that is equal to velocity. Slope of position time graph, that is equal to velocity. So if position time graph is a straight line, which means the object is moving with a constant velocity. In this graph, position time graph is not a straight line. It's curved, which means its velocity is constant. Its velocity is not constant. Velocity is changing. Now you can see this graph initially when it is moving up, it is curved away from the y-axis. It is curved away, which means velocity is decreasing. Velocity is decreasing. When the marker is moving up, its velocity decreasing, right? Velocity is decreasing. And you know that slope of position time graph is velocity, and when it is falling down, its slope is increasing, right? Its slope is increasing, which means its velocity is increasing. That is one thing. Second thing we have discussed, okay, at the beginning of this video, we have discussed when you throw an object up, its during upward motion, the direction of velocity is up. And you can see here, when you calculate the slope, it's going up, right? The line is going up, which means it has a positive slope during the upward motion. During the upward motion, the slope is positive, and during the downward motion, the slope is negative, which means during upward motion, velocity is positive and decreasing. During downward motion, velocity is negative and increasing. During upward motion, slope is positive and the slope is decreasing. That is why velocity is positive and velocity is decreasing. During downward motion, slope is negative and slope is increasing. Hence, velocity is negative and velocity is increasing. And at maximum height, its slope will be 0, which means at maximum height velocity is 0. Next, how to draw velocity time graph for this motion of the marker that we have thrown upward. So what happens when I throw this marker? It has the maximum velocity because I am applying a force, I am giving it a velocity. So it has maximum velocity when I throw it, and when it is moving up like this, when it is moving up, its velocity is decreasing. So when I throw, this is the time, right, like 1 2 3 like that, etc. This is the time axis. This is the we are drawing now velocity time graph. Okay, velocity time graph, and this is position time graph. So when we draw the velocity time graph, initially when you throw, it has the maximum velocity. When you throw, then when it is going up, its velocity is decreasing, and velocity becomes 0 when it reach the maximum height. At the maximum height, velocity becomes 0. Then what happens? It falls down, right? While falling down, velocity will be negative and increasing. So after that, it is falling. When it is falling, its velocity is negative and increasing. Same line, okay, same straight line. There is no bend. When you calculate the slope, it's a straight line, right? This velocity time graph is a straight line. What is the slope of velocity time graph? Slope of velocity time graph is acceleration, which means this graph has a constant slope, that is, it has a constant acceleration, and the value of acceleration during upward motion is negative 9.81 meter per second squared, and during the downward motion its acceleration will be 9.81 meter per second squared. The next is students, the next question, that is question number 18. Define free fall and free fall acceleration. So what is free fall? An object is falling only under one force, that is force of gravity. If I drop this laptop here, so only force acting on the laptop will be the force of gravity. Earth is exerting that force, right? That is called weight of the object. And what is the free value of free fall acceleration? The value of free fall acceleration is 9.8 meter per second squared during the when it is falling down. Then question number 19. Find the slopes and intercept of a position time graph and analyze the motion. That type of questions we have discussed how to calculate slope of a position time graph, and slope of position time graph, that is equal to velocity of the object. Then question number 19, find the slope and y-intercept. Yeah, that we discussed, right? Okay. Question number 20, relate the slope of velocity time graph to average acceleration. In a velocity time graph, if you calculate the slope, that is equal to acceleration. Okay, remember this. For a position time graph, slope is equal to velocity. For a position time graph, slope is equal to velocity. And for a velocity time graph, slope is equal to acceleration. And for a velocity time graph, area under the graph, that is equal to displacement. So from velocity time graph, you are calculating two parameters. You are calculating two quantities from velocity time graph. Slope of velocity time graph is acceleration, and area under velocity time graph, that is displacement traveled. Thank you students for watching this video, and if you have doubt you can ask. And I think almost all the questions we have discussed, and position time graph questions are repeating, so I have explained how to calculate the slope in the previous question. Okay, that is why the questions at the end that you will be able to do your own. Like that, equations of motion also, there are many questions repeating from equations of motion and free fall, and I try to explain almost all the questions as possible. Thank you again for watching this video, and good luck, best wishes for your examination.